In this video, I'm going to work several of the problems from the modeling problems practice in your lab book. And these are really great examples because it's a mix-up of the linear and the exponential functions, and so it'll help you practice distinguishing which ones are linear, so they're growing or decaying by a constant amount, versus which ones are exponential, which means they're growing or decaying by a constant percentage. The first one, number 1. It says the population of Quietdale is increasing at a rate of 23% each year. If the population is 12,500 today, what will it be in 4 years? So our variables for this one are time in years and our population. And since it tells us the population is increasing by a percentage, this is going to be an exponential function. So I'm going to type it in next to population. Let's see, the current population is 12,500. Times, and since it's growing, it's going to be 1 plus our rate, so 0.23, raised to, and I'm going to cell reference my years for my input variable. And then it says, what will the population be in 4 years? Well, that's an input value. We can just type it in, and we see in 4 years there will be 28,610.83 people. And even though you cannot have 0.83 of a person, I like leaving all of my decimals to 2 decimal spots just so I know that I did it correctly and I can see that y'all did it correctly. So next one, number 2. It says due to predation on the island, the population of shrews is decreasing at a rate of 17 animals per month. If the population of shrews in March is 715, how many shrews will there be on the island in October of the same year? Alright, so it looks like we're looking at months and our animals. And we're decreasing by 17 per month, so this is linear. It's decreasing by a steady amount. So the linear function, it's our slope, which is negative 17 times the number of months, plus our initial value, which was 17. And the thing to be careful here is we're measuring months since March is the beginning. So since we're looking for shrews on the island in October, we've got to see how many months is that since March. So March is considered times 0, that's the beginning. So we have April, May, June, July, August, September, October. So October is 7 months later. Let's just make sure we did that right. So March is 0, then we have April, May, June, July, August, September, October. Yep, 7 months later. And it says that we have negative 102 animals. Oh, you know what? I messed up my formula. I put a plus 17 here. It should be a plus 715. That's what I get for talking and typing all at the same time. So my equation is negative 17 times months plus 715, because that was our initial value. So we see 7 months later, there will be 596 shrews left on the island. That looks much better. All right, number 3. It says the Adventure Rent-A-Car Agency charges 45 cents for every mile driven. If the company charges a one-time rental fee of $27, what would it cost to rent a car that has been driven 250 miles? So here we're looking for the miles driven and the cost. Since they're charging us a constant 45 cents per mile, that's a constant amount, that's going to be a linear function. So it's going to be our slope times our independent variable plus the initial value, which is the $27 rental fee. And then if we're driving 250 miles, we see that it's going to cost us $139.05. All right, last one that I'm going to do for you, number 4. It says the concentration of a drug in the bloodstream decreases by 18% every hour. If an initial dose of 25 milligrams was administered, how much of the drug remains in the bloodstream after 4 hours? And then after what length of time will 1% of the dose remain? So we're looking at our time in hours, and then the amount of the dose. And it tells us that we're decreasing 18%. So since it's a percent, it's going to be exponential. So our initial dose is 25, and then 1 minus our 0.18 raised to our input variable. And I'm going to drag this over because we've got 2 parts, and that way I can show each part. So it says after 4 hours, we can just put in 4 for hours, and we see that after 4 hours, 11.30 milligrams will still be in the bloodstream. And then the second part says after what length of time will 1% of the original dose remain? Let's figure this out. We need to figure out what is 1% of the original dose. The original dose was 25, so let's multiply that times 0.01 to figure out what 1% is. So that's 0.25. So 0.25 is 1% of the initial dose of 25, and we want to know how long will it take to get down there. So we're trying to solve for hours given our dose left. So that's going to be a goal seek. So I'm going to click on my equation, go up to Data, What If Analysis, Goal Seek. And I want my equation to be 1%, which is 0.25, by changing the number of hours, and it's going to tell me how many hours it will take to get down to that dose. So it's going to take 23.195, so about 23.2 hours to get down to 1% of the original dose left.